Okay, we're gonna do power series. It's part 2. This time we're gonna take a look at what the effect of the derivative of a power series is. So we have this series like this, and this series is convergent to this function. So the series is Cn times x minus a raised to the n power. And if you write it down, you get z0 plus z1 x minus a plus z2 x minus a square plus c3 x minus a raised to the third power plus blah 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 plus cn x minus a raised to the n power plus blah blah blah. I laugh because my students laugh when I say blah blah blah. But anyway, the derivative of the series, it would be the derivative of the function. So in this case, if we take the derivative of this series, this is called term by term differentiation. It would be 0, because c0, when you take the derivative you get 0, and then the next term would just be c1. The next term would be 2c2 times x minus a raised to the first power plus 3c3 times x minus a raised to the second power plus blah blah blah, and then x minus a raised to the n minus 1 plus blah blah blah. The second derivative, so this, if you write it in compact form, it would be the sum as n goes from 1 to infinity, not from 0 to infinity, because this term dies out. So basically just, oops, I forgot the cn, so cn, and then we get n x minus a raised to the n minus 1. That would be the derivative. And the second derivative would be equals to 0, because the derivative of 0 is 0, and then the derivative of c1 is also 0, and then 2c2 plus 3 times 2 c3 x minus a plus blah 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 plus n times n minus 1 times cn x minus a raised to the n minus 2. And in compact form, this would be the sum as n goes from 2 to infinity, because there are two terms that are dead. And then this would be, you can put the cn first, and then n times n minus 1 x minus a raised to the n minus 2. And you can kind of see the pattern there. So this basically power series is infinitely differentiable. And we're going to take a look at a problem that kind of takes that into account. So suppose that we have this series that I'm going to write like this. Is 1 plus x squared plus x cubed plus x to the 4th power plus blah blah blah. And we can write this as the sum as n goes from 0 to infinity x to the n power. Alright, this is a geometric power series. We can write it as 1 divided by 1 minus x, and this series converges to this function as long as x goes from minus 1 to 1. Then if you take the derivative of this series term by term, then I'm going to write an equal sign here. So the 0, because the derivative of x of 1 is equals to 0, then 1, then plus 2x squared plus 2x. 3x squared plus 4x cubed plus blah blah blah, and then this will be the sum as n goes from 1 to infinity, so 1, because this term is dead, and then n x to the n minus 1, like that. And this would be the derivative of the function, And if you take the derivative of that function, you get 1 divided by 1 minus x squared. The second derivative of the function, which when you take the derivative of that function, you get, I think you get 2 divided by 1 minus x raised to the third power. In the series sense, this is called term-by-term differentiation. You get 0 plus 0, because again the derivative of 1 is 0, plus 2 plus 6x plus 12x squared plus blah 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 equals to the sum as n goes from 2 to infinity, because this term dies and this term dies, of n minus 1, n minus 1, and then x to the n power. But you start at n equals to 2. So this is one application of, okay, so, and then you can continue taking the derivative of this. All right, another application would be something like, suppose that you have this power series, and the power series looks like this. Let me see. Yeah, so it says, find the function for which we have this power series. So the power series is the series that goes from 0 to infinity, minus 1 raised to the n power, x to the 2n plus 1 divided by 2n plus 1, which you can write as x minus x cubed divided by 3 plus x to the 5th power divided by 5 minus blah blah blah. Then we're going to go ahead and take the derivative. We're trying to find f of x. We just have the series for it, but we're going to go ahead and take the derivative of that series. So the derivative of the first term is 1 minus x squared plus x to the 4th power, and the other one will be minus x to the 6th power plus blah blah blah. So we were able to find what the derivative of that series is, term by term. And it turns out that this series is a geometric power series. So this is 1 divided by 1 plus x squared, because the first term is equals to 1 and the radius, the ratio is x squared negative. So since we found that derivative, we can now find f of x, because that will just be the integral of the derivative, so 1 over 1 plus x squared with respect to x, and this would be tangent inverse of x plus c. But since f of 0 is equals to 0, because if you put 0 on the values of x for the series, you get 0. So this will give you 0 equals to tangent inverse of 0 plus c, so that will give you c equals to 0. Alright, this basically gives you the tangent inverse of x, and that series are the same. Not the same, I mean that series converges to the tangent function, tangent inverse function. So the x to the 2n plus 1 divided by 2n plus 1 is equals to that. And it's convergent from minus 1 to 1, even though the term on differentiation only says that the term only guarantees on the open interval. But you can check the endpoints right here, and it turns out that the interval of convergence is from minus 1 to 1, including both minus 1 and 1. This is important because when you put the minus 1, so tangent inverse of 1, you get pi over 4 over here. And then on the other side, you basically just get when n equals to 1, you get 1. When n equals to 0, you get 1, and then after that, you're gonna get 1 over 2, instead over 3, I think over 3, plus 1 over 5, minus 1 over 7, plus 1 over 9, minus blah blah blah. And guess what? We got something interesting here. We found out that pi is equals to 4 times this infinite series. 1 minus 1/3 plus 1 over 5 minus 1 over 7 plus 1 over 9 plus blah blah blah. Cool. pi is just an infinite series. Okay, this is it for this section. Bye bye.